This short video explains the concept of the auditory steady state response. Like ABR, ASSR is an evoked potential which is generated in the brain in response to sound. To record brain activity, we need to apply electrodes to the head of the patient. The most common montage is to have two reference electrodes, one on each mastoid. An active electrode, which is found on the high forehead, and a ground electrode placed on the low forehead or cheek. Just like any auditory evoked potential, we firstly need to present the stimulus to the patient. Many different stimuli can be used to elicit the ASSR, but the most common are narrowband CE chirps or pure tones. When a single stimulus presentation is delivered to the ear, it travels along the hearing pathway and is heard in the brain. However, the brain activity associated with this response is so small that it cannot be recorded using an evoked potentials device. In order to record the response, we need to change the stimulus, and in the case of the ASSR, we modulate the stimulus to create a steady state response in the brain. In other words, the brain activity mimics the modulation of the stimulus. This is shown in the image by the brain activity pulsating at the same rate as the stimulus being delivered to the ear. The modulation of the stimulus can be achieved by changing the amplitude, the frequency, or both. In this example, amplitude modulation is shown. The evoked potential device records this activity and averages the response over time. If a hearing response is present, then it must reach a defined level of certainty before it is classified as a clear response. This means that the response needs to be larger than the background noise, as well as occurring at an appropriate time-locked phase. Once these criteria are met and statistically verified, then we can be confident that the response recorded is a true hearing response. There you have it, an overview of the auditory steady state response.